Well, good evening, everyone, and welcome to the State of the Bays Address 2021. Welcome to the Anthropocene. Thank you for joining us. This seminar is part of the monthly seminar series that we hold at the Stony Brook Southampton campus. I'm Chris Gobler, Director of Academic Programs on the Stony Brook Southampton campus for the School of Marine and Atmospheric Sciences. So we give these once a month. The final one will be the first Friday in May, and that'll be the Shinnecock Bay Restoration Program, and I'll reference that again. But again, tonight is the State of the Bays Address, and this presentation would not be possible without the fine young men and women who work in the Gobler lab, shown here in happier times, or at least pre-COVID times, as you can tell by the photograph. I hope to get back to an event like this year. But really, these bright graduate students, research technicians, postdoctoral scholars are really the ones who are making all the difference and all the great discoveries that you'll see here tonight. And if you're interested in keeping up what we're all up to, you can follow us on social media, on all of the typical social media outlets. Okay, but for tonight's presentation, I'm going to break it up into multiple parts, as you can see here. I'm going to start talking about watersheds and then move into a little bit on public health, and then talk about water quality impairment, specifically what we saw in 2020, and then move on to talk about the Anthropocene, what I call the fierce urgency of now, and then end up on a hopeful note to wrap up the story. So to begin with, I'd like to start out with the idea and the concept of a watershed. And I talk about this a lot, the idea that all of Long Island is a watershed. And essentially what that means is that all of the activities on land and just below the ground will be influencing our sole source aquifer, the groundwater. And that's important because that's what is our drinking water source. And what's not extracted for drinking water then ultimately discharges into surface waters, where it will affect marine ecosystems. And when we think about this watershed and the fact that all of Long Island is a watershed, we can think about the role of that watershed with regards to being part of the Long Island community. And I'd like to borrow on a quote from Dr. Martin Luther King, something he called the garment of destiny. So he said, in a real sense, all life is interrelated. All men are caught in an inescapable network of mutuality tied in a single garment of destiny. Whatever affects one directly affects all indirectly. And this is the interrelated structure of reality. And then the author Wendell Berry put it another way, saying, do unto those downstream as you would have those upstream do unto you. So the point here is that we all share this sole source aquifer. We all are part of the watershed that's influencing surface waters, and there's a role for everyone. And in an ironic twist of fate, the people who live the furthest from the water on Long Island are the ones that have probably the most impact, at least on the drinking water end of things, and are impacting those people who are living closer to the water. And you can think about what that means, and that's there's some parallels to draw there between the garment of destiny and the watershed of destiny, and those upstream affecting those downstream. But to get a little bit more detailed and granular, we know what's been happening on Long Island, and specifically in Suffolk County, as we move from the 20th century and through the 20th century and into this century. We know how those changes in population is translated into effects on groundwater. And the studies have been done more than a half a dozen times across Long Island for every square foot of Long Island in Nassau and Suffolk County. And we now know that no matter where you are in Long Island, and no matter which of the more than 200 watersheds or subwatersheds you carve up, the most important source of nitrogen from land to sea is from on-site septic systems, more so than any other source. And we know that has consequences. And that was documented just last summer, as you can see here, whereby between the months of June and September, my lab began sampling all of our coastal waters, and documented all of what we call here water quality impairments. And this isn't guesswork. This is comparing the data and the observations we make to state and federal standards with regards to things like levels of oxygen, the levels of harmful algal blooms, and in some cases, more obvious things like a fish kill. And you can see no water body was spared in 2020. You can see areas where there was very strong clustering of events, but whether you could go all the way from the tip of Montauk all the way out to New York City, there was not a single water body without a water quality impairment. And we can make direct linkages to all of these impairments to overloading of nitrogen. But before we do that, I just do want to take a pause and talk about the implications of high nitrogen for public health. I showed you here that the mean level of nitrogen in our groundwater is now approaching 4 milligrams per liter. That's just the surface aquifer, what they call the upper glacial aquifer. Of course, many people in Suffolk County get their drinking water from Suffolk County Water Authority. And if you look at the different wellheads that are supplying that drinking water, you can see the nitrate levels are in some cases above that 3.8 milligrams per liter, in other cases below. But on average, you can see it is getting in that range of somewhere between 3 to 4 milligrams per liter. And if you put us in a national perspective, and that's done here, this plots out the drinking water supply for almost the entire country. You can see the top number here, 200 million Americans have drinking water with less than 1 milligram per liter nitrate. And then another more than 60 million have between 1 and 3 milligrams per liter. So what I'm getting at here is you can see we're kind of in the upper echelons of nitrate concentrations in drinking water. Now, on the one hand, the federal standard by the EPA for nitrate in drinking water is 10 milligrams per liter, and therefore we might say, well, this is not a big deal. On the other hand, there is emerging epidemiological evidence that suggests that this may not be a non-issue. So specifically, during the past decade or so, there have been multiple studies, and you can see an acceleration of those studies in recent years, most of them done by the National Institutes of Health in this country, suggesting that when you get above 3 milligrams per liter of nitrate in drinking water, not suggesting, the epidemiological evidence demonstrating that there's an increased risk for multiple types of cancers associated with high nitrate in drinking water, with the mechanism being the nitrate is converted to nitrosamines, which is a carcinogenic compound. It's the same reason you shouldn't eat a lot of bacon. There's nitrate and nitrite in bacon and other preserved meats that can turn into nitrosamines in your stomach as well. And this is a study I'm showing here. This data is from some scientists at Yale, but we've been collaborating at the university with scientists from the medical school. And for example, Dr. Paolo Buffetta is a very well-known epidemiologist recruited from Italy to the United States to be at the medical school. He and others put together this data set showing essentially that for multiple types of cancers, the incident rate in Suffolk County is greater than in all of New York State and also in the United States. And one of these, bladder cancer, which is the most exacerbated potentially, is one of the ones associated with nitrate. And if you localize where the above average incidences of bladder cancer are, they're in areas with elevated nitrate, and the same for kidney cancer. This is just circumstantial evidence, but it opens the question of there may be more to worry about when it comes to nitrate than simply effects in our marine ecosystems. We can say, regardless, that Suffolk County has higher levels of nitrate than 95% of the United States on average. The epidemiological studies are out there showing that the high levels of nitrate in drinking water we find in Suffolk County, there can be statistically elevated risks of cancer. And there are places on Long Island where the risks of cancers associated with high nitrate are higher than the state average, and in some cases the national average. But the state of the bays, of course, is focused on the bays. And as I alluded to before, there were multiple water quality impairments in 2020. You can see them all played out here. And many of these colored dots are harmful algal blooms, which we're no stranger to here on Long Island. We have the types that are toxic to humans because the algae make an actual biotoxin that can accumulate in the food web. And we have the types that are harmful to marine ecosystems, shellfish or fish. And there's been plenty of research to demonstrate that higher levels of nitrogen can make these blooms either more intense or alternatively more toxic, because some of the harmful algal blooms make toxins that are nitrogen-rich compounds. So to key in on this, we'll first start with blue-green algae. So looking at inland waters, lakes, ponds, and this is Lake Agawam in Southampton, and it's quite a view. You can see how the coloration of this lake contrasts with the coastal blue ocean. So you know this is an intense event, and these events are significant. The primary cause of the blue-green algae blooms, or cyanobacterial blooms on Long Island, are by a genera known as Microcystis, a genus known as Microcystis. And we worry about Microcystis because it makes this compound microcystin. This is a gastrointestinal toxin known to have carcinogenic effects. When it was first identified in the middle of the 20th century, the scientists called it fast death factor because it is such a potent compound. And if you follow the news this past year, last summer, there were a mysterious progressive die-off of elephants in Africa, specifically in Botswana. And it began with just a few elephants, and by late summer, it was literally hundreds of elephants. These are, of course, endangered species, so we worry about that from that angle. And as it turns out, in the final evaluation, as you can see from the image here, what was happening is that seasonally, ponds would form on the plains of Botswana, and they would slowly evaporate. And when they got to the point where they were evaporating, they accumulated high levels of these blue-green algae, cyanobacteria, that led to the die-off of these elephants. So just suffice to say, or simply to point out that you know something is a potent toxin when it can kill off a very large mammal such as an elephant. And that's why the EPA has strict standards for these toxins within drinking water, and also have standards for these toxins that are higher, but still there for recreational water. They don't want people drinking these compounds or swimming in these compounds, in which case they may accidentally consume them. And beyond humans, we also know that these compounds can be harmful to pets, specifically dogs. This study by the CDC demonstrated that there's been hundreds of dog poisonings through the decades. And in fact, we know for a fact that there's been a dog death on Long Island due to cyanobacteria, blue-green algae, and also that almost every year a dog gets sick from drinking water enriched in blue-green algae. And for that reason, the DEC has a very careful monitoring program across the entire state, looking for these blue-green algae to protect human health and warn people when the events do show up. And you can see here, these events have been increasing year after year. The DEC continues their monitoring program, and there's more and more water bodies found with these events. You can see that from this graph clearly. You can also see that in a plot like this, where you can see there's no shortage of green dots showing where these events have occurred. Now, it's a little hard to see, but firstly, you'll note there's sort of a north to south gradient, and the dots get a little bit more intense as you get further to the south. But what's harder to make out in this particular plot is the fact that there's no county in New York State with more locations having blue-green algae blooms than Suffolk County, where we are right now. In fact, 50 out of 62 states in the state, 50 out of 62 counties in the state have blue-green algae blooms. But again, the next closest one to Suffolk County has half the number that you find in Suffolk. This is a New York lake. It's actually Lake Erie, mostly located in other states, but it is partly in New York. But this is just backdrop to emphasize that while blue-green algae sometimes are promoted by phosphorus, that's often when the blue-green algae are known to be what we call nitrogen fixers or diazotrophic. They make their own nitrogen. But Microcystis, that I mentioned before, relies on what we call an exogenous source of nitrogen. It gets it from outside. It needs a nitrogen supply in order to form a bloom. And so these are related, and you can see the paper here that was with other scientists literally from around the globe who helped come up with this idea that the nitrogen affects the bloom intensity and toxicity. And that's no surprise, I mentioned this before, but you don't need a chemist in order to see the 10 nitrogen atoms in this compound. And the upshot is more nitrogen allows blue-green algae to make more of this toxin. Moving away from inland waters and moving to marine waters, again, your eyes can sometimes tell the entire story to you. You can look at this picture and know this is not a water body you would want to be swimming in. Something looks wrong. And this is Great South Bay. I believe this is summer 2019, but as you'll soon find out, this is not an uncommon occurrence. And that this is now, but it is a recent occurrence because this is an invasive algae that is new to Long Island. It's specifically known as Daisy-Siphona japonica, and you can see the species name japonica there is named after Japan. This originally is actually from Asia, but was invasive and spread through Europe during the 1980s and 1990s, colonized North America, just for the first time in 2007. And today I'm here to report to you that it has now spread all throughout the south shore of Long Island and into the Peconic Estuary. You see the map here, where you see a red dot is a place where we've affirmed the growth and presence of this seaweed. And it's not just present, but like the picture I showed you before, these are images all throughout Great South Bay. In the late summer, it can overgrow the bottom, and if it breaks off, it can then start washing ashore and create this sort of look. And unfortunately, it gets worse than this. These seaweeds start to decay on the shoreline, as you can imagine, on a hot summer's day. And short order, they might look more like this. In fact, I've seen the pictures of Great South Bay where it looks like this. Now, if you look at the landscape, that's not Great South Bay, that's actually in the Caribbean. But I point this out because I wanted to bring up this paper from the Lancet, the second most impactful medical journal in the world, pointing out just 2 years ago in a study that the overgrowth of seaweeds on shorelines is actually a significant public health concern because it can lead to pulmonary, neurological, and cardiovascular lesions. Specifically, the mechanism being that they release, these decaying seaweeds release hydrogen sulfide gas. And in this particular paper, they documented nearly 10,000 emergency room cases of people being brought to the emergency room because of exposure to these hydrogen sulfide gases because seaweeds are washing up on the shorelines. Different species, but the same mechanism that we've seen for this Daisy-Siphona on the South Shore, people complaining of high levels of sulfide, strong smell of sulfides. And so it's a human health threat, but in addition, it also is a threat to marine life. And so, for example, we've done experiments where we've exposed larval fish to either the living algae or to the algae that decayed away, as you might see on the shoreline. So the fish don't really mind the live algae, but when you expose them to the decaying algae, you can see there's almost complete mortality in a 1-week experiment. And interestingly, during these experiments, the water is bubbled, so it's not an oxygen issue, and the ammonium levels are not overly elevated. So we think it's an additional compound, and we're measuring those compounds right now that's causing this effect. We've also seen similar effects on hard clam larvae, and that's shown here, where we've taken larvae from hard clams and grown them in normal seawater with food, fed or without food, exposure to the seaweed, the Daisy-Siphona, living, or the Daisy-Siphona decaying away. And you can see there's significant mortality associated with this decaying seaweed. So it's a threat to human health, it's a threat to marine life. And the question is, well, why is it suddenly here? It's invasive, but why did it invade Long Island? Well, we've done experiments that were just published in the journal Biological Invasions, where we grew this seaweed and we repeated this experiment over an entire year, monthly, grew it under normal conditions, gave it more nitrogen, gave it more carbon dioxide, or gave it both compounds. And the summary of the results are shown here, essentially showing that all of these compounds have an effect, and there's an additive effect. So nitrogen loading promotes the event, CO2, probably associated with climate change, can promote it, and both of them can have an additive effect. But honing in on the nutrients, if we consider where the nutrients are coming from that are driving these events, we took that survey that I showed earlier and isolated those seaweeds in order to understand where is the nitrogen coming from that they're using. And you can do this with nitrogen isotopes and essentially get two answers. They might be using nitrogen derived from fertilizers. And when you measure something called their N15 or del N15 signal, that number then would be around -3. If they're growing off of wastewater, say from septic tanks, that number would be around 10. And so here's our survey, and you can see we've got about half of the sites being a perfect match to wastewater, and the other ones being far closer to wastewater than to a value of -3 in fertilizer. With the upshot being, these events are being, as I showed in the last slide, promoted by nitrogen, and that nitrogen is coming from wastewater. A final water quality impairment to consider before we move into some climate issues in the Anthropocene, I'd like to set things up, is actually oxygen. And so we've been working with News 12 and Newsday for the past 7 years to monitor water quality at 30 locations from East Hampton all the way out to the Queens border every summer. And in that data is getting put out on News 12 during the weather forecast. We usually run this from Memorial Day to about Labor Day. And we measure lots of things, but probably the most important measurements we've been making have been of oxygen. And we've been making continuous oxygen measurements, which has made all the difference. And just as background, as you probably know, but just to inform you that high nitrogen loading can promote algal blooms, those algal blooms eventually decay, and then you can think of a simple chemical reaction known as respiration, where that carbon from the algal bloom would decay away. To have that decay, oxygen gets consumed, and that leads to low oxygen conditions. This can be common, particularly during summer, and that's why the DEC has two very clear standards when it comes to oxygen. They have what they call their chronic and acute standards of 4.8 and 3 milligrams per liter, respectively. And so we've been monitoring the 30 sites across Long Island. What we found is that more than half of the sites violate that standard. That is, on an annual basis, have oxygen levels that are far below the acute 3 milligrams per liter standard. There's another handful that don't make the chronic standard of 4.8 milligrams per liter, and really just a few sites that are consistently at the highest level of DO that's required by the DEC. And again, mechanism being overgrowth of algae, too much carbon from algae, leading to degradation of that carbon and the decrease in the oxygen levels. And we know that low oxygen has consequences. There's been some very large historic fish kills through the year. You can see 2 of them here. And in 2020, we had reports more than 6 fish kills across Long Island during the summer that were associated with low oxygen. And you can see just some images here from Oakdale, another one from in East Quogue. And in many cases, you can see this is particularly the one in East Quogue. You can see literally millions of fish dying and then washing ashore. And this is under present conditions. So I'd like to transition now to talk about a little bit of future consideration, but also present conditions, the Anthropocene. So there's now a scientific consensus that the Earth has entered the Anthropocene, a new era whereby the activities of humans have become the dominant influence on climate and the environment, overwhelming the forces of nature. And it's very important to view our local ecosystems through this global lens. We need to be aware of what's happening globally and these global long-term trends in order to successfully manage and improve our coastal ecosystems. And the signs of climate change in 2020 were abundantly apparent. So, for example, here are global temperatures on average across planet Earth in 2020. And you can see that there are many parts of planet Earth that were setting all-time records of temperature. Um, and in fact, 2020 was the warmest year on record. And the fact this really, to me, was very concerning, because I'll just point out very quickly, you'll see this large band here. We were in, and we're presently still in, something known as a La Nina event, which meant that the upwelling of cold ocean water across the equatorial Pacific, which is a phenomenon that happens from time to time, but that upwelling was stronger. Excuse me, there's always upwelling, but it was stronger than usual in 2020. You've heard of El Nino, that's when that upwelling stops. But in 2020, we had La Nina. That upwelling was stronger. We had more cold water being brought up, and you can see that cooled down this huge part of the Pacific Ocean. Despite that very strong natural cooling event, we set an all-time record for temperatures in 2020. And that was the consensus from NASA. You can see from NOAA, Berkeley Earth Model, and other temperature models as well. And that has consequences for other parts of the planet also. We know with warmer temperatures comes lower oxygen, and we know our oceans are losing oxygen. And this shows over the last 50 years the percent decline in oxygen across the world's oceans. And in parallel, we also know the levels of CO2 in our atmosphere are rising. And many people thought, or there had been very much in 2020 with the pandemic and the lockdown and people at home, yes, there was less consumption of fossil fuels. However, that was not seen in our atmosphere. Really, this rise in CO2 is already built in. And even if we stop using fossil fuels entirely, that rise will keep on going, which is one of the reasons it's so important to make changes. And this rise in CO2 is leading to ocean acidification. And I don't have the time this evening to explain that, but it's reducing the pH of seawater, which is a threat, particularly to calcifying bivalves. And then on top of all of this, this paper by Don Anderson from Woods Hole and myself and others is just coming out. I think the preprint is available, showing that during the past 20, 30 years, we have a statistically significant increase in the fraction of the US coastlines that are covered by harmful algal blooms. And this was actually part of a global initiative of looking at these harmful algal blooms across the country. So the point is, in the Anthropocene, we have all of these stressors on the rise. Thermal warming, acidification, low oxygen, harmful algal blooms. And I have some friends from NOAA who I once introduced the National Oceanic and Atmospheric Administration. I once showed them this slide, and they encouraged me to continue to show it. At the meeting I was at, I called this the 4 horsemen of the Anthropocene ocean apocalypse. You may be familiar with the painting that doesn't have Anthropocene ocean in it. So that is the warming, the acidification, the hypoxia, and the harmful algal blooms. This is all happening now on our coastal oceans. And it's not just on the global level. We know things are also changing locally here in Long Island. So while we had a harmful algal bloom in the middle of the 20th century, we did have a period of no harmful algal blooms towards the end, but we've been in this era of the progressive increase of harmful algal blooms showing up during the past decade or two. And we're seeing our surface waters warm, frankly, at a rate that's exceeding the global average, particularly during some seasons and particularly during summer. This is satellite-derived temperatures for the coastal waters surrounding Long Island, South Shore and East End, NOAA-based satellites, and you can see the trend here, very strong trend. If we look at actual discrete measurements, the trends are not as clear because these are single points and made different times of the day over many, many years, but still, here's the Suffolk County data set for temperatures in Great Peconic Bay, and a very strong, significant increase in temperature. The temperatures that used to be rare are now common in late summer in the Peconic Estuary. Thanks to my graduate student, Stephen Tomasetti, who just pulled down this data from NASA-based satellites looking at Long Island Sound. Just since 2003, we're seeing a statistically significant increase in summer temperatures in Long Island Sound. Whereas in the beginning of this data set in 2003, that's when the data set began, we had temperatures, maybe the Sound would get to be around 20, and now it's reaching 22. It's 2 degrees in just 20 years. And similar pattern in the fall. Now, I can tell you winter and spring aren't significantly warmer in this same time frame. And that's the thing about global warming. It is asymmetrical. It's not happening in the same with regards to latitudes, with regards to time of year. But summer is actually the one where we need to look at the most, and you'll see why momentarily. And just to point out, when you have warmer temperatures, it means lower oxygen. Warm water holds less oxygen. So let me give an example of rust tide, Cockledinium. We had this all across the Peconics last year. It also spread all across Long Island Sound. This is an ichthyotoxic harmful algal bloom. We've seen this firsthand at the Marine Lab. It can also kill off shellfish. Again, seen this firsthand in the Marine Lab in Southampton. Now, on the one hand, this harmful algal bloom does better under high nitrogen than other types of phytoplankton do. On the other hand, we've also been able to show that the warming that we're seeing, particularly in our part of the United States, is leading to a longer bloom season for this particular harmful algal bloom, increasing by about 2 days per year since 1982, which essentially means if you go back, there was no window for these blooms in the early 80s, and now that window is more than a month or two. So again, thinking about the Anthropocene, we have warmer temperatures, we have more nitrogen, and that's giving us more intense rust tide blooms. Now, this has an effect on marine life, right? We know that warmer temperatures are stressful for example, bay scallops. We also know that this particular harmful algae can also be lethal to scallops. And as I just told you, warmer water means lower oxygen. And so there's oxygen stress as well. And to add things even further, this study was published in 2020 with some Stephen Tettelbach who was at Long Island University, is now at Cornell, and other scientists showing the probability of either bay scallops or hard clam populations experiencing a 50% decline at different levels of CO2. So acidification is dangerous to bivalves. And so what you can see here is that without acidification, there's a decent chance or some chance that the bay scallop population would be stable over the next 20 years, or, may not change and at least be stable for a 20-year period. That's pretty good. But if you add in acidification, it creates the certainty that this population will decline by more than 50% within 5 years. And again, we don't just have acidification, we have all the other stressors as well. And so when we think about the collapse of the bay scallop shell fishery that occurred during the last 2 years, we can think about the fact that, well, summer temperatures are higher than they've ever been. We had a very intensive rust tide last year. This species is very sensitive to acidification. We also know it's complicated. There's also a parasite, and Dr. Bassam Alam at Stony Brook University is teasing out now what role that may play. But all these things are probably interacting. And the single hypothesis that we can reject that had been put forward is that maybe there's not enough food in the estuary for the scallops. We know that those levels haven't changed over the past several decades. But there are the effects of climate change are obvious, and it goes beyond just scallops. Just as a reminder, at the end of the 20th century, Long Island Sound had one of the more robust lobster fisheries on the east coast of the United States. But Long Island Sound has become inhospitable to lobsters, and you can see that fishery is now extinct. It got too warm. There was a disease associated back then as well. But no one is fishing for lobsters in Long Island Sound anymore. And again, the temperatures became inhospitable. Now, that's not surprising in that this particular species is really what I would call a cold water adapted species. And so it's doing great up in Maine. Maine's actually getting warmer too, but that degree of warming is actually to a benefit, because it's not reaching the same highs that we have here. But there's other cold water adapted species that I have my eye on, and frankly that I'm a little worried about. For example, the blue mussel, which I think is obviously a staple of shellfish on Long Island. It was shown that from 1982 to 2005, the geographic range of the blue mussel declined by 350 kilometers. So from the region from North Carolina to Delaware, pretty much vanished. And so now, and that was just, as you can see, in that short period of time. And so what I've shown you a few slides back is that since that period of about 2005, Long Island Sound's gotten a lot warmer. And other estuaries are also getting a lot warmer. And there are mass reports from across Long Island, both East End, South Shore, North Shore. No one's seeing any blue mussels this year. I don't know where the blue mussel goes from here, but it's a cold water adapted species that is going to have a harder and harder time making its living as our waters get warmer. And so this is part of the Anthropocene, the whole idea that we have these parallel stressors going on all at once: warming, acidification, loss of oxygen, harmful algal blooms, and we have fisheries that are retreating. So when I say extinct in an ecosystem, they're not extinct entirely; they're just moving towards the poles, and that's what's been predicted. But locally things are collapsing. And on a local level, what will we do to combat global changes in temperature and global changes in carbon dioxide? There's not a lot. So really, our primary tool in the toolbox locally is to make sure our ecosystems are as resilient as possible against all of these changes by mitigating nitrogen. And to once again borrow on Martin Luther King and one of his quotes, again, with all deference for what the original topic was, he had the quote of the fierce urgency of now. And then as we are faced with the fact that tomorrow is today, we're confronted with that fierce urgency of now. And that there is such a thing as being too late. There's no time for apathy or complacency, to time for rigorous positive action. And I couldn't agree more. And obviously this is needed on the social front as well. But certainly in the face of climate change that we are not stopping, local action is needed to do everything we can to make our ecosystems resilient. And this is thankfully where I can talk about some hopeful news. And that is the fact that actually we live in hopeful times because despite everything that's going on I've talked about, things are afoot that are going to make things better moving forward and make our ecosystems more resilient. And so I'll start with Suffolk County Subwatersheds Plan that was approved by the Suffolk County Legislature in 2020. And I've used the quote before, and I'm going to say it again. With this plan, Suffolk County has gone from having the worst management plan for dealing with wastewater to the best. There's no county in the United States now that has a better, more science-driven and long-range plan for dealing with wastewater than Suffolk County does. So within this subwatersheds plan, they literally have carved up all of Suffolk County into literally more than 200 different subwatersheds and used a deep and careful assessment of the science to look at the circulation of the water quality, the amount of nitrogen, what the water is being used for, the circulation of the water, is it being used for drinking water, essentially to prioritize all these subwatersheds for upgrading from old septic systems to new ones that will protect the environment. And this is a very forward-looking plan. Even into phase 2 of the plan goes all the way to about 2050. And within that plan, they're looking to upgrade 218,000 septic systems. And the overarching plan goes well into the year 2070. And the modeling that they've done clearly shows the differences of having the plan and implementing it and not having the plan. And that's shown here. You can see in the upper left, if no changes are made, this is our destiny. And anything in the yellow or the orange or the red are those high levels of nitrate that are damaging to ecosystems and even a human health risk. But conversely, by implementing the plan, you can see here, we have very few of those red, orange, and yellow spots moving forward. And I'll emphasize beyond Suffolk County, the Nassau County subwatershed study is done. And while Nassau County on the South Shore is largely sewered, and most of the nitrogen into the bays is coming from a sewage treatment plant, when you go to the North Shore, it looks remarkably like Nassau County. So particularly looking at the northeastern section here, where there's really not a lot of sewering, the breakdown of where the nitrogen is coming from is almost the same as all of Suffolk County. And again, the dealing with all the septic systems between Nassau and Suffolk County, the over 500,000, when you add up those two counties, some watersheds plan is taking that on, specifically by now permitting through their Article 19 health code, the installation, and there's been installation of literally thousands of alternative septic systems, and these septic systems leading to nitrogen effluent that's less than 19 milligrams per liter. At the university's, the New York State Center for Clean Water Technology, that I'm directing at the university, our mission statement is to harness science to engineer clean water for the protection of public health and the environment in New York and beyond. We have a goal we call 10-20-30, and that's to have septic systems that get nitrogen down below 10 milligrams per liter, will cost less than $20,000 and will last more than 30 years. And on that $20,000 front, it should make everybody jump. But in happy news, there is funding from Suffolk County and from the state and from some East End towns that largely cover the entire cost of such upgrades. But at the center, we've developed something we call nitrogen removing biofilters that are made to significantly reduce the levels of nitrogen coming out of the septic systems. And they're meant to be built onto existing septic tanks. And they're built primarily out of natural products, sand and wood chips mixed with sand. And they're put in, you can see, just about 3 feet deep in successive layers to go through the process that we call nitrification and denitrification. And we build these things out in some cases with a liner along that wood chip sand layer in the bottom, or sometimes we have them unlined, as is shown here. In other cases, we might, we have the two layers decoupled, and we have the sand layer going to a wood chip tank. But in all cases, these systems are performing quite well. We published a paper just recently showing that we're able to remove 80 to 90% of nitrogen out of septic tank effluent. And that's shown here, the results for the 3 different systems. And I have here in the red, the line, the county standard, versus in the blue, what our own goal is. And we're meeting both of those goals with these systems. They also remove 90% of phosphorus and over 98% of pathogens. They also remove lots of things we don't want getting into our drinking water supply, like drugs and pharmaceuticals and personal care products. You can see the list here, more than 24 compounds. These were measured by Trisha Clyde, who recently defended her PhD with the center at Stony Brook University. And in all cases, these percentages are as good, or in many cases better, than sewage treatment plants. And an additional compound that we don't want in our drinking water is 1,4-dioxane. We also published a paper about this recently also. 1,4-dioxane is listed as a probable carcinogen by the EPA. Turns out that 1,4-dioxane is very difficult to get out of water, but our systems are removing it. And that was, again, is available in this particular paper. And I'll just mention that all the papers I'm highlighting here you can get for free online. I make all of my papers available for download. And so this study showed that actually household products contain a lot of 1,4-dioxane that are getting enriched in wastewater. But in happy news, the nitrogen reducing biofilters are getting the levels of 1,4-dioxane down, and not just down, but down below the new state standard. The standard for drinking water is now 1 microgram per liter. The water coming out of homes was above that. But on average, the water, not on average, in every case, the water coming out of our nitrogen removing biofilters was less than 1 microgram per liter. And so these systems are moving through the Suffolk County approval process. In January, our unlined systems moved from being experimental to being the piloting phase. We've just installed our 8th of these systems, which means that In 15 months, we anticipate these will be provisionally approved for widespread installation by anyone. And our other systems we expect to be approved hopefully also in 2022, or for the wood chip box one, maybe 2023. We've also taken the technology out of the wood chip box and decoupled it from these systems to the point where we now have something we call a polishing unit that can be added to any of the commercially available systems to get the nitrogen levels even lower, down below 5 milligrams per liter, which is going to be even more protective of our aquifer. And again, there's incentive programs in Suffolk County where these can be installed at almost no cost. And we have these systems ready. So if you're getting an IA system installed, talk to us and we can get one of these put on to go along with it. And I'm going to end with a new approach, or new approaches for reducing nitrogen within ecosystems. I mentioned in my very beginning that you can tune in a month from now on May 6th and hear about the Shinnecock Bay Restoration Program. And the teaser for that is that hard clam landings in Shinnecock Bay have increased 1,000% since 2011. So during the past decade, come on, zoom in with us a month from now to learn why. So a final mitigation approach I'm going to talk about are seaweeds. And we've done work in my lab on growing seaweeds, many different types for the past decade or so. But today I'm going to highlight one we've made a lot of progress on in the last several years. And before doing that, I really want to acknowledge the incredible work of Michael Dole. He's our bivalve and aquaculture restoration specialist in my lab. And he's brought to us a collaboration with Greenwave from Connecticut to get us going on growing kelp in New York. And I'll acknowledge that many of these slides are from Mike. And so, the question, why kelp? Well, it's actually now becoming an important aquacultured species across the Northeast US. It's, I believe, the second most aquacultured seaweed across the world. There's a species of kelp that's grown at enormous levels in Asia. It's an indigenous species, so we actually collect it for reproductive purposes out of Long Island Sound, for example. We're integrating this into oyster farms and something that's known as 3D farming. So if someone already has an oyster farm, they don't need any extra space to grow this. And importantly, this is a winter crop, if you will. It grows during the winter when many oyster farmers aren't doing much when it comes to a product. And I'll just very briefly state that you always want to have, as a farmer, multiple crops to protect yourself against downturns. And there were a lot of downturns on oyster farms due to COVID and COVID-19 in 2020. Not a lot of people were going to restaurants to eat oysters. So this would provide resilience against those sorts of downturns. So with the help from Mike and other people like Brooke Morell and Marissa Vasquez, we set up the first New York State DEC permitted kelp hatchery in New York State in 2019. And so that we grow up the kelp and spawn it in our hatchery, and then we can put the lines out on different oyster farms. And during the past 3 years, we've grown kelp on 10 oyster farms all across Long Island, from the South Shore to the North Shore, across the East End, and even all the way out on Fisher's Island. And just to give you an example of what that growth looks like, here are some of the results from 2020, showing you the pounds of kelp per foot of line. And you can see, firstly, that this is indeed a winter crop. It's put out in December. We're harvesting it somewhere between May and June. And the yields, particularly last year, have been very impressive, up to 9 pounds per 1 foot of line. And we're not putting out 1 foot of line. We're actually putting out hundreds of feet of line, often 100-foot lines and multiple of those. So with 3 100-foot lines, we're getting close to 1,000 pounds per oyster farm. And these are long, these kelp blades grow quite long. Here's Mike on a ladder with about a 12-foot long kelp blade. And I should mention, I failed to mention, but we'll mention now, when we began this project, the dogma was, well, you can grow kelp in deep water, but don't try to do it in a shallow estuary. Well, Mike proved that wrong. In fact, our best yields shown here were in Moriches Bay, where on low tide, the water is only about 1.5 feet deep. And still we're getting the best yields of all the locations. So it's not just about water depth. And beyond growing this for oyster farms, I'm most interested in what these kelp do ecologically. They take CO2 and nitrogen out of the water. And if you're paying attention, those are the things we don't want in the water. And they're adding oxygen, which I told you is in short supply, and they're maybe even combating harmful algal blooms. So we know they take up a lot of nitrogen, and the data shows that as well. And interestingly, the amount of nitrogen they take up is perfectly proportional to the nitrogen in the water, which only makes sense. But when you put them in really high nitrogen locations where you need to remove a lot of nitrogen, they do the job and respond. So we're getting much more nitrogen per gram out of the kelp grown in the South Shore than we did in our Long Island Sound site, which made sense. That Long Island Sound site was not towards the west, but more towards eastern Long Island Sound. We also did the same nitrogen tracing with the kelp, just like we did, I showed you with the seaweeds earlier, and it's getting its nitrogen from wastewater. Now, it doesn't mean it's taking up nitrogen. This is just based on the exact nitrogen atom. That nitrogen is decoupled out of the wastewater. But again, this tells us it's mitigating nitrogen and it's mitigating wastewater nitrogen. And based on the amount of nitrogen it's removing, Mike's done the math. We don't have any 1 acre kelp farms, but if we did, you could be pulling out, I told you it's thousands of pounds just on 3 lines, but the amount of nitrogen is not the full weight of the plant, of course. But in a 1 acre farm, you could get up to 220 pounds of nitrogen. And that ends up being the equivalent to 8 to 18 advanced septic systems. So this is another tool in the toolbox. It doesn't replace what we're doing because you can never get this to full scale to combat all the nitrogen, but it certainly moves the needle. And then finally, on the harmful algal bloom front, I shouldn't say finally, there's one more thing after this, but on the harmful algal bloom front, can seaweeds affect harmful algal blooms? Well, we know that they can, but we never tested kelp. But when we tested kelp, we wanted to test it against a cold water harmful algal bloom. The harmful algal blooms go through a temporal succession during the year. We find this one particular species in the spring, and it's frankly the most troubling of all the harmful algal blooms. It makes saxitoxin. This is a potent neurotoxin. It's literally 1,000 times stronger than cyanide. And, sad to report, a man died in Alaska this past summer from consuming shellfish with saxitoxin. This organism is all over Long Island, and we've had 7 different locations across Long Island where the shellfish beds have closed because of high levels of saxitoxin in the shellfish. So this is a human health threat. So what happens when you try to combat this Alexandrium with the kelp? Well, Peter Silvers, my PhD student, has done studies to look at this. And here on the right, you're seeing what these cells look like when they're healthy. On the left, you're seeing what happens after they're exposed to kelp. And what you can see is they start to shrivel up and literally they will lyse and lose their innards. In experiments with large amounts of Alexandrium in the water, so not in the lab, but actually the wild Alexandrium you find growing out in the bays, if you add the kelp there, you can significantly reduce the amount of Alexandrium in the water. And then he also has done a very important experiment asking the question, well, if you expose mussels, if mussels get toxic when they're exposed to Alexandrium, what happens when you expose them to Alexandrium, but the kelp is present as well? And the answer is the mussels end up being less toxic. And that's shown here. You can see a significant reduction in the amount of saxitoxin in the mussels. And importantly, the levels found in the shellfish is actually below the US FDA closure limit compared to when we didn't use the seaweeds. These seaweeds may also help with ocean acidification. Remember, ocean acidification happens from the rise of CO2 as plants or algae, these seaweeds take up CO2. We've already published on the ability of some macroalgae, some seaweeds to mitigate ocean acidification, actually to help bivalves. You can see that in this paper. This was published specifically on ulva, but we've been doing experiments recently with kelp, and you can see some of the results here where we have acidified water and we let that water go with and without kelp. We should see pHs in the realm of 8 And you can see the kelp get that water into that realm much quicker than if you don't have the kelp present. And again, look at all of Peter's experiments. He was able to show that seaweeds, both kelp and other species, are always raising the pH of seawater and therefore combating ocean acidification. So I would consider kelp and other seaweeds, their ability to create a halo effect and on these shellfish farms to protect those shellfish farms against things like harmful algal blooms and ocean acidification. They won't combat all of our problems, but they can be useful, particularly on these shellfish farms. And then a final point is that beyond helping the shellfish farms, these seaweeds can potentially be turned into fertilizers. We know there's a lot of fertilizer used on Long Island. It's not the most abundant source of nitrogen, but it's number 2. And we've, in my lab, done experiments trying to convert these seaweeds into fertilizer. And what I'm showing you here is a graph with no x-axis, because as we reach the end here, to play a quick game, can you identify which of these 3 sets of fertilizers is Miracle-Gro and which 2 were made from seaweeds? You're looking at the amount of solutions made from seaweeds and from Miracle-Gro, and the amount of nitrogen and phosphorus we're able to get in those solutions. So let's see how everyone did. You can see we can get a solution out of kelp to look just like Miracle-Gro. And when we use seaweeds from summer, like ulva and other such species, we can get it even more enriched in nutrients. And beyond just creating a nutrient-rich solution, here's my son Luke holding up some eggplants that we grew in some experiments. Can you guess which one was grown with the seaweeds? And that's the picture that tells 1,000 words, but we've also have the data to go with that, where we get heavier eggplants, we get bell peppers that are heavier and more bell peppers per plant. And we also, this experiment being slightly more complicated, our positive control being Miracle-Gro, our negative control being adding nothing. But in this sort of experiment, what we see is an effect that the kelp fertilizer being better than nothing, not as good as Miracle-Gro. The summer seaweeds close, but when you combine these, it actually ends up being better than even the Miracle-Gro, or at least similar. So with that, I am done. So to wrap up and conclude, I've shown you this evening that excessive nitrogen loading from wastewater is an ongoing threat to coastal ecosystems, economies, pets, and human health. And I've shown you the data that climate change is accelerating and the effects on our marine ecosystems are becoming more and more obvious by year. And that leads to the fierce urgency of now. We must take action because the climate change, we need our nitrogen action to outpace the rate of change due to climate change. And the primary mode for that is going to be upgrading septic systems to reverse water quality impairment and to protect our drinking water, frankly, from organic contaminants. And then finally, I've shown you that seaweeds do hold promise to locally mitigate water quality and impairments like harmful algal blooms and acidification, and may be a very potent fertilizer. So with that, I'll thank you for your attention, and let's see if we can go to a question and answer session. And so for that, I see there's already some chat. You can also, on the lower bar, if you see something that says reactions, under that, you can potentially, should be able to press the raise hand button, and I can try to address people that way as well. And let's see what we have for some questions already. Going back into the chat here. A question about what is happening in Russia. And so, yeah, that is the warming of the Arctic. And someone already said that, and apparently it's still warm up there in Europe, and that's just going to continue. And thankfully, we're in a school of marine and atmospheric scientists at Stony Brook University. So our atmospheric scientists can give you some good information on that. Let's see. So here's a question. What other carbon-based materials have you tested in the NRB? Do you think carbon materials that have a greater surface area than wood chips would help with even greater amount of nitrogen removal than wood chips alone? And in fact, the question also mentioned biochar. And let's just see that that question's from, I think, Debbie Aller. And in fact, we are doing work with biochar. And it looks like that it can have effects beyond just being a carbon source. It does, as you mentioned, Debbie, has more surface area. And so we're actually exploring that right now to see how that might affect. It also might be able to assist in direct nitrogen absorption. So that's an exciting opportunity, and certainly biochar also helps fix carbon and preventing it from going into the atmosphere. Paul Stacy asked a question, and I should say that Paul Stacy informed me that he had an article written called Welcome to the Anthropocene 10 years ago. So I'm late to the party, but better late than never. Paul Stacy asked, what nitrogen benefits might be derived from invasive macroalgae, which are very competitive in shallow waters, including Daisy siphona and gracilaria, and even ulva? And will they outcompete laminaria with some reductions in nutrient loads? So one on the last question, will they outcompete laminaria, which is kelp? I don't think they will, because of the way that the kelp is growing relative to certainly not the kelp that we're farming. On some surface areas, they might, particularly the Daisy siphona, which also is a cold water species. And, you know, nitrogen-derived benefits from the invasive macroalgae, they're certainly taking up a lot of nitrogen. There's no doubt about that. But the problem is, unless you're farming the seaweeds and you're harvesting before they die off, you have the trouble of them then re-releasing that nitrogen all at once. Debbie Aller had another good question. What types of fertilizer products are you making with the kelp? Meal, liquid, or both? And so we've been exploring, Debbie, with both. So we've worked with both dried seaweeds, but we've also worked with making a liquid out of them. And we've had success with both. It so far seems like the dried approach is more reliable, but we're exploring the mixing of the kelp in a liquid form to see what sort of advances we can make on that. Another question is, where can the resources you mentioned be found? And so the best place, I presented many papers tonight. If you put in if you've ever been to the site, and my lab website, you can go to there where you go to publications, but what that's going to lead you to is my Google Scholar site. And again, for the past decade, I've made it an effort to have all of my papers be free for public access. So if you go to Google Scholar and put in my name, or you go to my university webpage and you go to the publications, all of the things I'm talking about that we've published on should be available to you. Some of the very recent things, for example, the kelp work, we do have a publication coming out on kelp, but or two coming out on kelp, but those are forthcoming, more is forthcoming, but a lot of the stuff that I've shown you can get through those websites. Question here is on maintenance needs of IA systems and their final destination of their constituent materials. With regards to maintenance needs, in Suffolk County, if you install an IA system, you have to have an operation, you have to have a maintenance contract with someone who will come and make sure the system is performing adequately. And under those cases, they're going to come at least once a year to make sure everything is functioning as it should. And the final destination can be from an IA system into an existing leaching ring, or it can be into a standard drain field. There's a question about the kelp and the fertilizer and whether it needs to be extracted. And so actually probably we had a collaboration with a vineyard on the East End, Macari Vineyards. And in doing that, we explored not just extracting it, but treating it in a few different ways. And so I think there are benefits to be had just from having the kelp out there. And I know, for example, Mike Dole in my lab has put it in his garden, and he swears that it led to better water retention, and it also potentially has some antifungal properties to it. So it maybe need not be extracted for all its benefits. Question about how much land is needed for the wood chip systems. That really depends on the size of the home. Different size homes have different, the larger the home, the bigger the size needs to be. But I think some of these are on plots that are, as I'm going to say, in the range of 20 by 40 or 50, and hopefully they're, but again, it's going to depend on how big the home is. And that's mainly the drain field. Some more questions here. Question about how bad are cesspools versus septic tanks? And that is a great question. And the answer is they're no different. And this is a little bit of an unfortunate reality. When people say, oh, my septic system's not failing, so that's good. Turns out that standard septic systems, whether they be a cesspool or septic tanks attached to leaching rings or a failing system, they all are designed to not remove any nitrogen. And in fact, as crazy as this is going to sound, if you have a failing septic system, you might actually be removing more nitrogen than if you have one that's not failing. Because if it's failing, that means the wastewater is at least getting to the surface and being processed. Whereas the standard old systems are meant to just go deep into the ground and right into the groundwater. My friend and colleague Kurt Bresch asked to speak more about polymacroculture. And so that is polyaquaculture. And are there oyster farmers currently incorporating seaweeds into their businesses? And so the answer there is right now, all the kelp growing is really experimental, but that I believe is about to change. As I mentioned, we've already worked with 10 different oyster farmers, and many of them are interested in making this a business. Now, there's a lot that needs to happen for that to be a lucrative business, but they are eager to do so. But that gets to a whole nother aspect, and that other aspect being there needs to be a market for this. And so fertilizers would be just part of that. There's a lot of people interested in this as a food product as well. In some cases, a gourmet food product. And frankly, for this to be a sustainable business, there's going to need to be multiple markets for it. But there certainly are oyster aquaculturists who want this to be part of their farms. My friend Marco is here, and Marco asked, are we dealing with other invasive algae or just Daisy-siphona? And really, actually, there are many invasive species out there when it comes to the seaweeds. And so, there's an invasive gracilaria, which is one of the most common red macroalgae out there. Some of the other seaweeds may be as well. I see Marco there. Good to see your face, Marco. Thanks for tuning in. And so, yeah. Oh, hi, Julia. Good to see you also. And so Daisy-siphona is the most recent player, and to our surprise, is starting to have clearly has some ecosystem effects as well. But it's not the only one out there. That's for sure. Louise Harrison asked if wood chips are removed from an IA system, what is their well, she's asking if the wood chips are contaminated. And so that's a good question. And in fact, our wood chip box is meant to be replenished. So you can actually replace those wood chips. As it turns out, we know for a fact that when the compounds are broken down in our nitrogen removing biofilters, they're done by the bacteria on the actually in the sand. So there could be some contaminant. Certainly, you wouldn't want to put those wood chips right into your garden per se, since they were being bathed in wastewater. But I don't know. We'd have to think about what their final deposition would be. Okay, another question. Are there ways for individual organizations to help with research or outreach? Well, let's see. I think, outreach, I think, could be as much as talking to people you meet and thinking about how everybody has a nitrogen footprint and how yours maybe could be changed. And on research, we do sometimes take volunteers, although we usually give our priority to Stony Brook University's students, but there is sometimes room for volunteering also. Steve Schwartz, who just put his camera on, asked a question asking, is it better for individual sewage processing systems to have individual sewage processing systems and centralized sewage treatment plants? Great question, Steve. And so, in an ideal world, we could just hook up everyone to a sewage treatment plant, because that makes actually the operation and maintenance quite simple, and it's not on the homeowners, and people could just pay a bill. But the problem is the way Suffolk County was built out, doing that now is very difficult. And in fact, there's been some studies done, even in the more populated regions of Suffolk County, where it could cost up to $100,000 per home or more to create a new sewer district and then put those homes on that sewer district. Whereas, it's in the $20,000 range for the IA system. So there are some opportunities that actually Suffolk County and the place have been taking advantage of, whereby if homes are near a sewer line, they can then be hooked up, and that can be cost effective. But the idea of being able to put up sewage treatment plants all across Suffolk County is not logistically feasible for reasons of cost and space. But thank you for your question, Steve. I appreciate it. Next, a question for Howard. What are the salinity requirements for growing kelp? Well, we've done well in estuaries. So that is that we don't need full ocean salinity. So that's a plus. We do know that they're not going to grow in freshwater. They're not going to grow in highly brackish water. And, the exact pivot point of when it will no longer do well, it's probably the salinity's in the 20s, but we don't quite have the final number there. Jack Schultz from West Hampton Beach High School has asked a question. And his question was, if the blue mussels were to be removed from the environment, similar to lobsters, what would the environmental impacts be? And that's a great question. We know that blue mussels presently are found most commonly in the coldest waters that we have left. So usually around ocean inlets on the South Shore, because they can't hack the warm temperatures further within estuaries. They're also quite abundant in places on Long Island Sound. But if we lost them, that's losing part of what we would call the ecosystem filtration. And so that's what these bivalves are important for. If you come to our lecture and on May 6th, you'll hear more about that. But yeah, we'd worried about the loss of ecosystem filtration. And then there's, that's my first really simple answer. But this is one of the things about changing, just climate change in general. And, again, I'll just emphasize, remember, what we're talking about changes of just a couple of degrees centigrade that can be enough to sort of tip the balance of these ecosystems. And that's the one thing that it's easy to forget, but is important to keep in the front of your mind, that small changes in temperature can have a big effect. And Jack, more to your question beyond, my off the top of my head answer is, well, we'll lose the filtration. But the more concerning things are the things that I can't answer. That is, what are the ecosystem services that those mussels are currently providing that we'll lose? We don't have a definitive answer to that. There's certainly also a food source for many animals. They're also probably a habitat for other animals. So, and that's one of the concerns with climate change. Small changes can have a big effect, and things are happening quicker than we can keep track of what the effects ultimately may be. Here's a question from a seawolf, a member of the Stony Brook University community. Laura asks, what is something the average seawolf can do to help with these issues? Well, I think, as I said, certainly we all have a carbon footprint. We all have a nitrogen footprint. And so we can think about that and think about what are the things we can do to minimize those footprints, to put less carbon dioxide into the atmosphere, to contribute less nitrogen to the watershed. On the nitrogen front, certainly upgrading septic systems is a big one. Using less fertilizer is a big one. I'm not gonna, no one has to make a wholesale change to their diet, but I will just mention that it's well known that vegetarians and vegans excrete less nitrogen per year in their wastewater than do omnivores and carnivores. So if you wanted to make If you needed another motivation to make a diet change, there would maybe potentially be another one. Paul Stacey, who been talking about the Anthropocene for quite some time, had a comment here, and his was, let's see, one very powerful management tool is revegetation of landscape and stream shore buffers. E.O. Wilson's half-earth concept provides compelling evidence. Is there hope for such naturalization of the landscape on Long Island? Well, I think that's a great idea, and I would love to see more of that. And the important thing also, and this gets actually right back to something I forgot when Laura said, what can we do? It's well known for people amongst the scientists that natural undisturbed habitats, land, forest, a backyard, for example, that's not landscaped, removes more nitrogen than does a developed landscape, and certainly then does an impervious surface. And so this is what Paul Stacey is referring to, is revegetation. If we have more land that goes wild and is revegetated, just from the nitrogen that comes from the atmosphere, more of that will get taken up by the vegetation on that revegetated land, and less gets into the aquifer and therefore into surface water. So, whether there's hope for that, I hope there's hope for that. And I know, for example, on the East End, the community preservation funds, the whole process begun by Fred Thiel, those funds are used to, on the property transfer taxes, to buy land and also to preserve water quality. And so, and I know there's actively areas where people are just buying land and not rebuilding it. So, okay. The lecture comment from Susan Jewett is that the lecture should be made available far and wide to help educate the public. And in fact, it will be. So this is being recorded, and this will go up on the SoMAS YouTube channel, and my lab page, my laboratory has a YouTube channel. We'll put it up there as well. And maybe we'll send out an email to folks to let them know about that. Yep, and here's a great comment from Steve Schwartz. Yep, mussels also hold the shoreline together against erosion. Entirely true. Although then Julie mentions, and I agreed, that also it's a lot of shoreline is rib mussels rather than blue mussels, but there are areas that because of the byssal threads of mussels where they do hold structure together. Another point here is your group noticed there seems to be little to no live mussels this spring. Yep, that was a big point that I was trying to make. And very sad to say that it seems to be a consensus that there is no set of mussels this year, and a lot of the ones from last year are not there. And people are scrambling to find blue mussels. They're actually used as a sentinel against harmful algal blooms, to know when there are harmful algal bloom toxins and to look for pollution. So we're looking for a plan B now, because nobody can find blue mussels, and that is problematic. My friend Sean Barrett from Hampton Bays, and the head of both Eat More Kelp as well as Dock to Dish, says eat more kelp, and you can learn more about that from him. And see here, and I think we're near the end. It looks like we are. So I think I've held everybody here long enough. So I thank everyone very kindly for their attention and their interest in the topic. And like I said, this has been recorded, and we'll get this out to everyone as soon as we can. And I encourage all of you who are interested to come on May 6th and see the lecture about the Shinnecock Bay Restoration Program, and learn more about the 1,000% increase in hard clam landings in Shinnecock Bay during the past decade, despite everything else going on. So with that, I will again say thank you. It's good to see everyone, and thank you for attending. I appreciate it, and I will hopefully see everybody soon. And who knows? Actually, the last thing I'll say is that This is year 2 of doing a Zoom version of the State of the Bays. In happier times, we actually, State of the Bay Symposium would also feature about a dozen graduate students presenting their research. And so I'm optimistic we'll be back to that next year. We'll have a Zoom option for people, I think, as well. So those who can't attend will be able to, but hopefully we'll be back to live in person, and you'll get to hear from all the great, wonderful graduate students working out of Southampton as well. So with that, I'll say thank you and good night. Have a good week. Thank you very much.